Question number 7 is about. Oh, just wait. Why is not copying? Okay. So, so we have question number 7. Explain, oh sorry, complete table 7.3 3 to give three differences between DNA and tRNA. We have already discussed this in some other paper. So, what would be your answer? What is the main difference? Okay. Ribose sugar, uracil, single strand, thymine, or uracil instead of thymine. What else can be? The shape, okay, and this tRNA would be like a leaf, like a clover leaf. Okay. Then, what about the cordons or anti-cordons? Have any anti? Exactly. Okay. Let's move to question number 2. Okay, sorry, part 2. Scientists investigated rRNA in liver cells. This is the figure that they have shown used to isolate the ribosomes from the liver cell. The detergent dissolved lipids. So, cell contents after large organelles have been removed. So, what is the next part? Wait, let me copy the next part. So, the scientists broke open the cell to reproduce a suspension of the cell content. Describe how the scientists would remove large organelles from this cell content. Which method they are going to use? Centrifugation. So, what is the basis of centrifugation? How? Okay, so we say that these large, if they are large particles, they settle at the bottom, and the lighter one or the less dense one, they actually gather at the top of the test tube. If this is a test tube, this is the same test that we use for blood. So I'm giving you an example of blood because it's easy to explain rather than ribosomes. So blood have many cells like RBCs, WBCs, and the platelets. Is it so? So when we spin it at a very high speed or more rotations, what will happen? These cells they settle at the bottom, being more denser. And plasma, it would be collected on the top, being lighter in weight. Okay, so this would be the same situation here. The larger organelles they settle at the bottom, while the lighter one would be in the top layer. Lighter organelles, let's say, in the top layer, and this top layer is known as supernatant. Okay, or we can say supernatant layer. We need to use a scientific word. So we take the supernatant layer. Okay, and then again, if we think that okay, large organelles are not fully removed, we'll centrifugate one more time to remove if anything is left or any denser organelle is present, that is going to settle at the bottom, and we again take the supernatant. Okay. Explain the position of the bands of ribosomes in A and B in figure 10. Okay, these are the different bands that are shown, the free ribosomes and the bound ribosomes, one without detergent and one with detergent. So, what is the reason? In tube A, we have free ribosomes and we have bound ribosomes. on the endoplasm. Yes, it would be denser. And what would less dense? Yes, it would be less dense or dissolved by detergents. Okay, let's move to the next question then. Okay, we have fully explained it. Okay, so next question says, okay, so again, the image is not available, so we cannot do this, but can we? Yes, we can do 8.2. Volume ratio is given weight. So we cannot do this as well because we cannot calculate the upwards, the values are not given, or we can calculate it. Let's just calculate. Wait, let me copy paste. A table is given, so they have asked about the values, how to calculate it. So volume divided by, sorry, surface area is to volume ratio is this. Mean we have surface area here. Ratio mean is divided by volume. So how can we figure it out? We just divide it, divide and tell me the answer. Yeah, no, the surface area to volume ratio. That ratio. You need to find the ratio. So both values are given. Surface area is also given here. The volume is given 2.3 into 10 raised to the power 4. Do you know how to do this on calculator? I guess you know this. How to put exponent on the calculator. Okay. So we need to divide them and find the answer. Okay, wait. Let's do it. It would be 1 by. Okay. It would be tough for you, I guess. Okay, it's bit uh, you can say bit technical. What you need to do when you calculate the surface area to volume ratio, we need to keep one value 1. Okay, I guess you haven't taken the chemistry. I've asked you earlier as well. When we take the molar ratios in calculations in in our like the chemistry one, what we do in the balanced chemical equation, we consider one thing as 1. That is for standard. Like it's our standard. Like they have used this one as a standard. Okay. Now, if it is, for example, 7.4 into 10 raised to power 3, and this one is 2.3 into 10 raised to power 4. So, which is the smaller value? You think 2.3 is a smaller value? Okay, let's take this as a no. It's not a smaller value because the exponent is 4. Okay, now we have to take this one. Okay, divide both sides with 2.3 into 10 raised to power 4, because we need to take something as a standard, which is 1. 2.3 into 10 raised to power 4. Can you please divide and tell me the answer? I guess now you can easily divide. 7.4 into 10 raised to power 3 divided by 2.3 into 10 raised to power 4. No, no, don't multiply. Just tell me the answer for this one. Okay, now, um I'm telling you one thing. You need to follow that. Let me see if I can use some scientific calculator over here. What you need to do, just 7.4, press 7.4, and then there is a button for x. If it's with decimal, if x is not over there, then it must be written 10 raised to power x. Press that and 3. Again, how come your answer is like 32? Because we have a smaller number in the numerator. It should be in decimals. Is there any exponent at the end? 32, is there any exponent at the end? No? Okay. Okay, let's do this. Wait. Let me do this. I'm using calculator. 7.4 exponent 3 divided by, we have 2.3 exponent 4. Mine answer is 0.321. Wait, I'm sharing a screen with you. Okay? Another screen. Wait, where is the this class? Here. I'll show you how to do this. So let's see the Chrome. Okay. Can you see the calculator here? Yes. Okay. So let's clear it up. It's 7.4. Here we have exponent 3 divided by 8. Oh, sorry, 2.3. 2.3 exponent 4. Look, my answer is 0.32. Okay, you need to check whether your calculator is on degree. It's written on the very like top. It's on degree, then it should be 0.32. No, then it would give a wrong value. What you need to do, just press the mod and select the mod degree. You must have that one on your calculator. Okay. Okay. Um, Actually, this one is not the right calculator. What you need to do here, you would have a round button in the center that would say mod. Okay. 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 Ask your teacher to fix this because teachers know how to do this. Ask your math teacher and he or she will fix it on like DEG. Okay. Done. Is it also saying RAT on the top? Degree still? Okay, do one thing. Let's convert it. 7.4 divided by 23. It would become 7.4 into 10 raised to power 3. And again, if you want to convert this in 3, it would become 23 into 10 raised to power 3. So you can also divide 7.4 divided by 3, divide by 23, sorry. Can you turn on your camera? I can fix it for you. Like, or we can do it after class. Can you use some online calculator? Okay, please. Use some online calculator because we need these values to be correct. Okay, the next one. Here we have the value. Here we have the answer 0.13 divided by 1, and here we have 1.1 into 10 raised to power 4. Now we have to calculate this value. How to find this? Simply 0 divide 0 point or 1.1, not 0 point 1.1. Okay, are you listening, Adiba? Okay, so here, for example, we have x. How to find x? We take x on this side and 0.13 over this side. It will become 1.1 into 10 raised to power 4 divided by 0.13 is equal to x. Now, what would be your x? Okay, let me do it as well. It's 1.1 exponent 4 divided by 0.13. Yes. Okay, 84615. Okay, okay. Let's convert this because they have asked for only two round figures, scientific figures, and with two only significant figures. So we are going to use these two first words. Now, wait, if at the end of everything there is a decimal, end of any number there is a decimal, this is a basic math. Now, when you're moving, when you move this decimal towards the left, it would add, means 1, 2, 3, and then 4. Okay, so it would become 10 raised to power 4, and the number would be 8.4, or if we round it off it become 8.5. Okay, so it would be 8.5 into 10 raised to power 4. Okay, keep in mind whenever we take ratios we need to consider one of the factor as 1. Okay, the damage to the gills causes uncontrolled cell division in the cell. Now, what is the effect of that uncontrolled division? Definitely the tumors. Other than surface area to volume ratio, describe one way this uncontrolled cell division changes the gills. What would be the effect on gills if there is uncontrolled growth? So there would be, first thing, there would be more cells. So what would be the effect of more cells? The filament would be thick and it would take more time, or what you have said, longer diffusion distance. Is it so? Longer pathway or distance for diffusion. Okay, now explanation. Why this longer uh, pathway? Actually, this one is explanation, the longer distance for diffusion. So, if there is longer distance for diffusion, what would be the effect? Slow gas exchange, or that would be like slow rate of diffusion first of all, and then Thus, there would be low gas exchange, or there would be uh, lesser absorption of oxygen. Okay. Okay, let's move to the next part. Let me copy it. Where is the question paper? Here. So we they have shown us the which system, a single circulation or a double circulation. In so here is a diagram. Do you have paper in front of you? Wait. I'll copy it. So here is a diagram of a circulatory system. Is it a double circulation or is it a single circulation? This one in fish. No, it's single. Single mean it passes through the heart only once while going back to the body. So it's a single circulation one. So they have asked about the differences between the single circulation and the double circulation. What are the differences? Number one. Okay. Four chambers. Two chambers. So blood passes through the heart once in a circuit in a fish, while blood passes through heart twice in a circuit. Okay, through heart twice. What else difference? Okay, two veins and two arteries in a double. Okay, two veins, two arteries. While here we have one vein and one artery. One vein and one artery. Okay. What else can be? It can be related to pressure. There would be lower pressure in single circulation, while in double circulation, because yes, the left part is pumping it with greater pressure. The pressure is high. Sorry. Okay. So let's move to the next question. Just give me a minute.